Now let's talk about one of the conceptual things that trips up newcomers most often in Rust: the difference between expressions and statements. In many languages, these terms are used loosely. In Rust, they have a precise, important meaning. Statements end with a semicolon. They perform an action but produce no value. Technically, they return nothing. Expressions, on the other hand, do not have a trailing semicolon. They evaluate to a value. This is critical. Blocks, if statements, loops, all of these are expressions in Rust. They produce values. We also have functions and returns. Functions automatically returns the last expression in the body. You don't need a return keyword unless you're returning early from a function. Look at the code box. We have a statement. Let y equal 6. This performs an action but returns nothing. Then we have a block expression. Let x equal, now we have curly brackets. In the curly brackets we have let z equal 3, z plus 1. And we have no semicolon. X is now 4. This block is an expression. Its value z plus 1, which is 4. Note that z plus 1 has no semicolon. That's what makes it an expression that returns a value. Finally, we have the following expression. Let status equal if check. We have curly bracket. Inside the curly brackets we have OK, else, and then inside the curly brackets we have ERR. This entire if else is an expression. It evaluates to either OK or ERR, and the value is assigned to status. Now let's look at the code. We have two functions, the add function and the greet function. The add function takes two i32 parameters. So these are signed integers of 32-bit, and it returns a i32 as well. The body is just a plus b, no return keyword. There's no semicolon. So this means that this expression is going to be returned. The last expression is the return value because there's no semicolon. And we also have the greet function, which takes a string reference, and it has no return type annotation. That means it returns nothing. Or we also call it unit. It just has a side effect of printing. The key concept at the bottom here: expressions, no semicolon, return values. Statement with semicolon, do not. Now let's go back and see it in action. So we want to, here we are returning a plus b. We have two i32 parameters, and we're just adding the 2. So let's do that. So print, we're going to print out add function so here is calling the function add, which is going to add these two numbers, so 5 and 7. That's all, and that's what's going to be returned. And for the second one, we're not returning anything, but by calling this function and putting something in the parameter, we're just going to be printing whatever we put in our parameter. In this case, we're putting a string, call it Rust. So the side effect will be, so what will be printed out will be hello Rust. So let's save and let's run. Okay, so as expected, here we're returning a plus b, simply returning a plus b, and here we're just taking our whatever name we put in our parameter and we print it. So this is not returning, this is just printing. Now let's look at this, the semicolon trap. This is important enough that it gets its own slide. Let's look at a common mistake. We have two statements. We have a statement here which returns something. So this is the incorrect statement. And here we have the correct expression because we don't have a semicolon in what we are returning on our return value. In the incorrect version, we have a plus b with a semicolon. The semicolon turns into a statement which returns nothing. But our function signature says it should return an I32. The compiler will reject this with a type mismatch error. In the correct version, we remove the semicolon. Now, a plus b is an expression that evaluates to an I32. Everything is consistent. The compiler is happy. The critical concept. A statement performs an action but returns nothing, also known as unit type. An expression evaluates to a value. Every time you see a strange type error in Rust about expecting a type but you got this unit, check for an accidental semicolon on your last line. It's one of the most common beginner mistakes. Let's reinforce the expression concept with control flows. The classifier function returns a string slice. The entire body is a single if else. Each branch returns a string literal, positive, negative, or 0. No return keywords. The if expression evaluates to one of those strings. Now, looking at the second function, first even from. Here we use loop, Rust infinite loop keyword. When we find an even number, we do break n, which returns the value n from the loop. The loop expression evaluates to whatever you break with. The key concept is this: everything is an expression. Loops and if blocks evaluate to values that can be assigned or returned. This is a powerful design. It makes code more concise and compositional. Tuple returns. What if you want to return multiple values from a function? In Rust, you use tuples. A tuple is a fixed size grouping of values that can be of different types. The syntax is just parentheses with comma separated values like t1, t2, value 1, value 2. 5 things to know about returning tuples. First, multiple returns. A function can return a tuple to pack multiple values into a single return. Let open bracket a comma b close bracket equal. This is clean destructuring. You can unpack a tuple directly at the call site. This is called destructuring. Third, ad hoc grouping, no struct needed. Tuples are perfect for simple related pairs like coordinates, like x, y, coordinate, or ranges, min, max. You don't need to define a whole struct. And fourth, strict types, type preservation. Each element in the tuple keeps its specific type. A tuple I32 bool, bool is a different type from open bracket bool, I32 close bracket. Best practice, know the limit. For complex data or more than 3 fields, prefer a name struct for readability. Tuple with many elements become confusing. You assess them as .0, .1, .2, so on. Here's a real example. The min-max function takes a slice of I32 values. So there's I32 and it returns a tuple of a pair tuple I32, I32. We start with min and max, both set to the first element. We loop through all the values and update them. At the end, we return min max. So, these are tuple, no semicolon. In main, we call min max and immediately destructure the result into low and high. This is clean, readable, and requires no boilerplate struct. Simple as that. So let's run it. And yeah, just as we expect, the minimum is 1, the maximum is 9. Pro tip: tuples are ideal for returning lightweight grouped values without the boilerplate of defining a struct.